Right, we're looking at one of the questions from the work that was set this week. So this question is: identify as oxidation or reduction the formation of NO2 from NO3 minus ions in the presence of H plus ions, and then deduce the half equation. So first of all, looking at whether it's oxidation or reduction. So we're forming NO2, so that's on the right hand side, and we're starting from NO3 minus. Now the temptation here is to look at the charge as -1 and say the species on the right has lost an electron and is therefore oxidation. But what we need to do is look at the oxidation state here. So oxygen stayed the same oxidation state on both sides, but the nitrogen's changed. So we need to look at the oxidation state of that. So let's do the right hand side first because that's easiest. So I've got two lots of oxygen, and we know that oxygen's always -2. So that's -2. And we know that it's NO2, it's a molecule. It's got to add up to 0. So if that's, if that's -4, if the oxygen's -4 in total, then the nitrogen's got to be +4. If we look at the left-hand side, this is a bit more complicated because it's a negative ion. So it's got to add up to -1. So remember, the sum of the oxidation states of the elements has to add up to the charge on the ion. So -1 equals the nitrogen that we're trying to find out, and 3 of the oxygen, which we know is always -2, apart from the exception of the peroxides that we know about. So that becomes -1 equals N minus 6. So if I take that 6 over to the other side, that becomes +6. So I'm adding 6 to both sides to cancel that out. +6 minus 1 equals N. So then N equals +5. So on the left-hand side, the oxidation state is +5. On the right-hand side, it's +4. So it's going from +5 to +4. Right, so if it's going from +5 to +4, it's becoming less positive. And if it's becoming less positive, that's because we're adding electrons. So therefore, it's gained electrons. And we know from our GCSE, hopefully, that oil rig oxidation is loss, reduction is gain. So if it gained electrons, it's got to be reduction. So therefore, it's reduction. So that's the first part of it. We've then got to deduce the half equation for the reaction. So I'll just put a line under that because we've done the first bit. And I'll write this out again. So NO3 minus to go to NO2. So what we've got to do here, so first of all, we balance the element that's changing oxidation state, but that's already done because there's 1 nitrogen on both sides. And then we need to look at the oxygens. So there's 3 on the left-hand side and 2 on the right-hand side. So if you remember, in order to balance the oxygens, we add water. So I need 1 more oxygen on this side. So I add water, which is H2O. And now I've got 2 hydrogens on the right-hand side. I need 2 hydrogens on the left-hand side. And we balance that, remember, by adding H+. So I'm adding 2 H+. Now all I've got to do is balance the charges by adding electrons. So on the right-hand side, there's no charge at all, which means on the left-hand side, there's got to be no charge. So I've got 2 plus over here, and I've got -1 there. So hopefully you can see that to make that 0, I need to add 1 electron. So therefore, my overall equation, so my overall half equation that I've written is 2H plus E minus plus, so I've got to put my plus in there, NO3 minus gives NO2 plus H2O. Okay, that's the end of the explanation. Thank you for listening.